Welcome, everybody. Happy
Hey.
Hey, get your official word in. So I want to very briefly wax philosophically. Feel free to tune this out if you don't think I'm a wise guru, but I was just thinking about something over the weekend. There's somebody in this class that's been having a lot of technical difficulties in getting the VPN to work and getting the files they need and getting AutoCAD to work. And so I just, I probably wasn't as patient as I should have been in helping them work through all these things. And it just got me thinking about the reasoning behind what we're doing in this class. And I firmly believe that you could all go out and find YouTube videos that are already out there and tutorials and figure out how to use AutoCAD on your own if you wanted to. And so really kind of the point of this class is to catalyze you into actually doing these things and actually putting in the effort to learn things. And so when I was just thinking about the struggles this person was having, and really how those struggles are kind of valuable in and of themselves. It's educational to go through and fail at things and figure out why things are wrong, because it actually makes you think more about what it is you're learning. Whereas if me or anybody teaching a class just shows you like, this is the exact right way to do things, and this is the way you do it every time, you almost don't even need to think about it. You're not really learning. You're kind of just reproducing something. And it's, in my opinion, it's not as educationally valuable. And so that's the approach I'm really trying to take in this class, is to hand you tools and point you in the right direction of different challenges and really get you thinking about stuff, as opposed to just saying, this is how you do it every time. And that's a very difficult challenge. I'm getting a notice that my internet connection is unstable. Can everybody hear me and see me?
Yep.
Okay.
Yes, sir.
Yeah.
Cool. So, I don't want you guys to think that I'm preaching as some kind of, I think I'm some kind of genius or expert tutor, because there's a lot of video evidence out there that I'm a bumbling idiot that stumbles over his own words all the time. But this is just something that I think about a lot anytime I'm in a learning situation, is just the value of making mistakes, and you've probably learned that in your in all your different labs in school. Is like, really, at least for me, I learn the most when I screw up the lab and have to figure out why I screwed it up and why my results aren't good. So anyway, the last comment I had on this is just, if you're all familiar with the Socratic method of, whenever somebody asks you a question in a learning environment, you're supposed to answer with a question, right? So if somebody says, why do you use object snap in AutoCAD to connect things? The Socratic method would be for me to say, well, what's the value of using object snap to snap two lines together, right? Which is super annoying. But it is valuable from an educational sense of getting people to think about why they're doing things, as opposed to just telling them the answer of, well, it's just the best way to do it, right? So the most powerful learning is self-taught, self-teaching, or autodidactic learning. And if you've checked out on the YouTube channel where I'm posting these videos, one of the subscribed channels on there is AVE, which stands for Arduino versus Evil. And it's a totally inappropriate, sarcastic Canadian guy that's a super genius. He works in the mining industry. I highly recommend checking out that channel, but interspersed between all profanity and irreverence. There's a lot of educational philosophy kind of along the lines of what I'm talking about. So if you have the time, I highly recommend checking out that channel. It's super valuable. Okay, now you guys should all wake up, those of you that I've put to sleep with that, and fire up your AutoCADs and open up all those drawings we had open last week. So I'm going to share my screen real quick.
Are we continuing what from last time?
Yeah, so this is going to be part 2 of what we were working on last time. So if you weren't here last time, hopefully you watched the video. Hopefully you have something along these lines where we have these 2 drawing borders. We got rid of the content that was in there already. There's a numbered index on the side. We have a little bit of content started here, and we're gonna make a 2 drawing set. Just as an example of multi-drawing sets. So real quick, does everybody have this line in, circuit breaker, and 2 fuses with a reference line and this little doohickey here?
No.
No?
Can we go over that a little bit?
Yeah, for sure. So all I've really done here is taken content from these example drawings here. So that was drawing 8, 9, and 10 out of the example set that I sent you guys.
Yeah.
So does everybody have that drawing set open and available? Because we're going to be grabbing more content out of there as we go through.
Yes.
As usual, yeah, thank you, Sal. I'm going to take the resounding, deafening silence as confirmation that you do indeed have the example drawings open. So what we did is last time, let's go ahead and rehash that, get our AutoCAD muscles working. So we're going to go to drawing 8, and in the model space, we're going to grab this content. Oh, I just realized kind of made a mistake last time. So grab all the content off drawing 8 and just do a Control-C and then a Control-V, okay? And then do a quick resize to scale, or do a quick scale to resize this content to this border. Because last time I copied content from this drawing into our working drawing without rescaling it, which means all the text and everything is too small. So what you're going to do is you're going to grab this, move. I'm going to go through this really fast because this is stuff we've done before. Okay, so I'm going to type move, grab the corner of this, snap it to the corner of that, select all of this content and type scale. Specify my base point for scale, type R for reference, grab this corner and this corner to set my scaled content, and then snap it to this corner, right here, to set my reference scale. Cool, now that's all rescaled. Now, if you're wondering why we're just cannibalizing content out of an existing drawing rather than drawing all this from scratch, well, the answer is you're not going to draw stuff from scratch very often. There's no point in reinventing the wheel when 90% of the time the CAD content you're going to be creating, you're going to be following some conventions, and there's going to be existing content from a similar project that you can reference and use to your little heart's desire. Okay, so I want something that looks like this for my power distribution. So I'm going to grab, I'm going to do one important thing first. I'm going to draw me a reference line in my border before I insert content into my border. Okay, so I'm going to find the midpoint on my line, which is right here, and just draw a reference line there. Okay, And then I'm going to change the layer for that. I'm going to change that to the stuff layer. That's a John Davis naming convention. I tend to name stuff stuff. And then I'm going to open the layer properties panel up here. And I'm going to go ahead and change the stuff layer to be colored yellow. And I'm going to rename the stuff layer. I'm going to try to rename the stuff layer, rename layer to reference. Okay. And that's going to be my reference layer that I've talked about before, that at the end of this, I'm just going to go hide because I don't want it anymore. So now what we're doing is we're going to draw a power distribution drawing, and I'm going to do that. I know in my power distribution drawing for a panel, I'm going to want an incoming ground, an incoming live line, and an incoming neutral line. And so I'm just going to grab all this existing content here. Make sure you grab all that text. Okay. And I'm going to type copy. And then for my copy reference point, I'm just going to grab in the middle of this power supply right here. Grab that line. And then I'm going to scroll up into the drawing, my new drawing border. And I'm going to drop it in there. Okay. Now, this is scooted down too far. I don't like this, but we're going to fix that in a minute. One of the other things I don't like is this content that I'm stealing was for a heavy duty industrial panel that had a lot of juice coming into it. And so it had this big mechanical disconnect. I know in our panel, like we talked about last week, I don't have a big mechanical disconnect. I just have a circuit breaker. So I'm going to select that breaker, and I'm going to delete it because I don't need it. Okay.
Could you zoom out really quick so I can see how much of that drawing you pulled?
Yeah. So I pulled, what I wanted to pull is the ground circuit, and then definitely everything feeding into the first box. So it's this first UPS box here.
Okay, but not this.
So we'll probably go back and grab this content down here later.
Okay.
And so actually what we can do is just go in, well, just leave it for now. So the next thing I want to highlight is that this line here is dashed and this line here is solid. Can anybody tell me why that might be? Take a wild guess. There's no wrong answers here. Nobody? We have no volunteers as tribute. Okay, so the reason this line is dashed and this line is solid is because these dashed lines are coming in externally from an external power, from an external panel. Doesn't necessarily need to be power. And these lines here that were coming off that mechanical disconnect are installed in the panel. So they're present. And so basically what this is delineating on our drawing set is what wires get shipped in the panel to the installation site and what wires need to be brought into that panel once it's installed at the installation site. Sorry. Got to shut off my air compressor this morning. Okay. So we got a chat. Yes.
That sounded like a gnarly guitar riff.
Ah.
I thought you were gonna start shredding it, dude.
Start shredding it in our Pantera style. No. Okay, so I want to delete this upright line because, like I said, I'm getting rid of that main disconnect. I'm going to go ahead. Actually, wait a minute. I'm going to do this right and smartly. So because I got rid of that main disconnect, I have all this unused space here in this drawing. I got a big chunk of space that I'm not using that I want to take up because there's no reason to use up all that space unless I need it. So I want to go in here and select all this content because this is all the content that we're going to shift up. And then I actually want to select, let me think about how to do this. Okay. I'm going to draw another reference line from the top of this line, come across through here, and just drop it anywhere past that line. And you'll see why I did that in just a second. Okay. So I want to grab all the content here, all these lines I brought in, as well as these two upright lines. Okay. And I'm going to type move. And then I'm going to click this reference point and bring this line up here. And now you can see, hopefully, why I drew this reference line. So now I'm going to, because I'm going to select this line and I'm going to type trim, and I'm going to get rid of all that extra length there. And so I just scooted up all that content without having to do a whole lot of adjustment. And the last thing I need to do is change this line here to that dashed or hidden and extend that line over there. Over here. Oh, that's good. So I think when I had to readjust this red line to bring it out over here, I think that was actually a misalignment for the original drawing content. So just always be on the lookout for that. Okay. Now this looks pretty good, but it's still scooted down too far. If you look at the source drawing, this lettering is up against the top of the border. And so I just want to grab all that content, do another move, and just bring it up by hand to right about there. And so I picked where to align this, just eyeballing it, so that it lines up with this, with one of these numbered indexes over here. And if you want to check that, you can extend it out. Okay. So actually what I should have done, and I'm going to do it right now, is make sure that that really aligns properly with one of those numbered index points. So I'm just going to scooch it down just a little bit until you can see that line is just below the 003. Okay, and I'm going to snap it. Okay, so now that's a line. I'm going to unextend that line back to where it's supposed to be. Alrighty. And then now I need to look at all my wire numbering. So I have L1 in, and then that's magically turning into 1L1. Well, that's a problem because that doesn't make any sense. You need your wires to be labeled the same on both ends. Okay, the reason that is because on the original drawing, you had L1 coming in, and then it went to a breaker, and then on the other side of that breaker, it was 1L1. So I need to change that to just be L1 so that we're self-consistent with our wire labeling. Okay. And then this wire right here on the old drawing, because that content was further down, is now going to be on line 3. So I need to change this from being 0060. I'm going to change it to 0030. Okay. Do that consistently throughout. And then do the same thing on this wire. Okay, and this L2 looks good. This thickness call out looks good, so I'm gonna leave that. Okay, now, the one other thing is these call outs of where the power is supplied. I need to change that. So double click on that. Oops. I'm gonna just, because I don't know where that power is gonna be coming from, I'm just gonna change that to X's. So it's obvious temporarily, like you're gonna need to go in and fix that on the drawing. This is gonna be installed in my home, which has 10 amp breakers. And I don't know what circuit that's from again. So just change those to X's, change it to 10 amp. Okay. Now, as Sam was asking earlier, what content do we need in here? Well, the way this is gonna be wired, it's gonna come into a circuit breaker, and then it's going to go to fuses, and those fuses are gonna be jumpered. So I wanna probably get rid of all this content here. So select that, delete it. And again, it's okay to delete some of this stuff because we can always go back to the source where it came from. We're not losing any content by making these deletions. Okay. So now I want to grab this fuse. I'm going to move it. That wasn't good. I don't know what I did there. Get rid of that. Okay, type move. Select my base point and move it up onto this wire here. Okay. That's too close. There's got to be a better way to do this. 1 second. Oh yeah, that's right. Okay. I'm gonna undo that. Sorry, I forgot how I planned to do this. So what I'm gonna do is grab this little line here, move that up. Oh wait. Hang on. I'm gonna look at the physical hardware. Give me 2 seconds. I'm trying to remember how this is wired. It's been a while since I actually looked at this. Okay. So the way this is wired, it comes into the circuit breaker, and then on the back side of the circuit breaker, there's a wire that comes out and goes to fuses. And what I'm trying to do is make sure that this is all aligned so that you have room to draw in more components in the middle. So sorry for the confusion. I know how we want to draw this now. So I'm going to get rid of the lines here. I'm just going to move these out of the way for now. Okay. And I'm going to draw another line coming down from here, down just a little bit, over, and I'm going to mouse over here and align it with this dot, the left-hand dot on the circuit breaker. Come down again. And then jog it over a little bit. And I just realized that's not exactly what I wanted to do. Okay, select these 2 wires here, type move. Click on this part here, move it over, and snap it onto what used to be that corner. And then grab this wire and extend it out. Okay, now that's pretty much what I wanted it to look like. And now I can go down here and select this fuse. and the wire label. And make sure you grab these two little weird angled lines as well. Type move. Click on this junction point between those two little weird lines and the circle on the fuse. And then go snap that onto that wire right there. Okay. That looks basically like what I wanted. Okay. Now, okay. Now, come over here and draw a line from the center of this 0 in front of the 5. Oh, just clicked too soon. Draw a line from the center of the 0 on the 5 down to the center of the 0 on the 7. Okay. And this is a reference line that we're going to use to set our spacing for all the rest of the fuses. Okay, so drag that over, grab that line, type move, stick that onto that little point right there. Sorry, that's the wrong spot. Type move again, and snap that onto the center of the circle on the fuse right here. Okay, so now we're ready to start copying fuses. And I happen to know that in my panel, so select the fuse, select this reference line, and also select these two funny looking little red lines here, and type, not move. Sorry, I can't talk and type at the same time. Type copy, okay? Gosh dang, I can't get all the content I need. Okay. Select all that stuff and type copy. And then you're gonna copy that fuse 4 times for a total of 5 fuses. So 1, 2, 3, 4. So that gets us 5 fuses total. Ah, shoot, I didn't get the fuse. Okay, so I'm gonna copy that fuse, or that fuse label. And again, so I just grabbed that text and typed copy. So now I'm specifying the base point. I'm going to specify the center of that circle. And then now I can copy it onto the exact same spot in all the fuses by hitting that same spot on all the circles. Okay. Now all these fuses are jumpered together with jumper wires. And so that's why we have these funky little looking lines right here, these 2 diagonals. So what we need to do is close the gap on those. So I can just use a line to go end to end. And then rather than individually going line and then clicking escape and then hitting line again, I'm just going to draw one of these lines and then I'm going to copy it, because that's actually going to be faster than manually drawing each line. Okay, so same deal, copy, jump those together, jump, jump, bam, done. Okay.
Is this supposed to be on the reference label?
It's not. So that's something that I just realized I've been doing, and we need to change. So select all those jumper wires, and then also select this wire here that I drew before. Make sure and get all segments of this wire, and change it to the L1 layer. Okay. Bam. So you see now, we just changed the layer that's on. This looks kind of shoddy the way I drew this. To be honest, I should have spaced it out differently, but that's okay. We're just gonna roll with it because this is an example drawing. If you're doing an actual drawing, you definitely want to make this look a little bit prettier, but this is just for demonstration only, so we're gonna roll with it. So you saw there was this wire here this is sticking out too far. So I'm gonna trim that off. Get rid of that labeling, and then get rid of this little diagonal doohickey there. And then that looks pretty good. That's pretty much where I want it to be. So now I just need to go and fix my numbering. So I know this is on 00550. This one is 70. And so on and so forth. And even though I don't have actual wires shown here, I know they're gonna be there, okay? Now, those reference lines are kind of funky, so I just wanna show you real quick how we can get rid of them. You go up here, you click the down arrow on the reference, and you turn that light bulb off. And you say, yes, turn off the current layer, because that's what I want to do. And those reference lines go away. Cool. So now, real quick, I got to resize the other side of my drawing. And I'm going to do that by taking this content. Spoke too soon. I'm going to delete these two lines that are sticking out for now. And then I'm going to draw a line temporarily from this end of the fuse out here. Oop, sorry. I got to turn my reference layer back on. Okay, so now I got my reference line. I can move this content up to be on that reference line. Alrighty. And then I'm going to draw another reference line from the second fuse. So I know where this bottom content needs to line up. And the reason I'm having to do this is because on the drawing that I borrowed this from, these lines were spaced every 3 index lines, not every 2. And just for the sake of condensing my content, I'm making the spacing to be every 2. That's kind of just a stylistic choice. Okay, so I need to shorten this line up. And then I'm going to copy all of this content. Copy. Boom, boom, boom. 1, 2, 3, 4, 5. Cool. And as you can see, these are labeled jumper bar because these are actual jumper terminal blocks. Looks good. Oh, I need to show one more jumper here. I'm going to select that. Content. So the jumper bar and the label. Copy. Whoa. Apparently I typed circle and not copy. So reselect that, copy, select, move, oh.
Jumper bars to be the same size as the space between the fuses?
Yeah.
Okay.
So in the real physical world, you can buy jumper bars that are specifically sized to space between your components. So I'm just cleaning up the spacing here because it's not really precise.
Mm-hmm.
That's fine. And I'll show you what that physical component looks like in real life. Okay. Now, in this drawing, we would really need to go in and clean up all of this labeling, renumber it, and just make sure it's accurate to what we're drawing. Same thing, we would renumber all these fuses. For the sake of expediency, I'm not going to do that right now because we're trying to burn through this, and this is, again, I'm trying to give you the tools, not show you exactly how to do every single minute point. So the next thing I want to do is come down to our source drawing that we're cannibalizing content from and grab these arrows. So just highlight that, and you can actually just cut and paste this content up into our working drawing. Okay. And what I want to do is grab this arrow and type move. Come over here and drop this on this terminal point right here. And as you can see, there was already a label there. So now we got this weird thing where you got overlapping labels. Get rid of those. And I'm going to do the same thing with this arrow down here. I'm going to move. And drop that right on the fuse there. Get rid of this label. And then you would need to renumber these labels and make sure that this blue, white, whatever, is actually accurate to what you're going to use to wire. So, and then this arrow needs to say, so in our case, this is 120 VAC. Capitalize that VAC to line. And we're going to go to the next drawing. So I'm going to look over at the next drawing. You know what? I'm going to make this come in on line 1 because there's nothing in here and I can do whatever I want. So I'm going to say to line, oh, but wait, that isn't line 1. So this that we're drawing in is drawing 1. This is drawing 2 in the set. Drawing 1 ends at 29, which means this, when I relabel it like I'm supposed to, is going to be line 30. So I'm going to say, I know that's going to line 30, okay? And then I need to know what drawing number that's going to. So I look over here, drawing 2, okay? In my set, I'm going to say C, drawing, wow, that says drawing. C, drawing 2, okay? And that's how we do reference arrows between drawings. So I need to do the same thing over here. 120 VAC to line 30. C drawing 1 or C drawing 2. Alrighty, super awesome. Okay, so now I've done that. Now what I can do is select. I need a reference line. So what I'm going to do is copy these arrows over onto, from drawing 1 over onto drawing 2 to show the incoming references. And what I'm going to do is just say line, and I'll put that right underneath the 001. I'm going to draw a reference line. Okay. And that's just to help me locate where I'm going to drop the content in as I migrate it. Okay. So I'm going to grab this content. So this arrow and this arrow. And I'm going to copy. I'm going to come over here. So I'm just going to drop it right here for now because I'm going to move it. Okay. So now I've copied my arrows. I need to decide where in this drawing border, I want those arrows to be located, and I'm going to locate them out towards the edges as much as I can. So I'm going to draw a couple more reference lines here. I'm just going to pick right in the middle of this 8 is going to be my incoming reference line. The reason I picked that 8 is because on the other side, I can sort of mirror this by putting it on the 1, bring that down. This is kind of an arbitrary choice I'm making. It's not that big a deal. I'm just drawing reference lines so I know where to drop my content. Okay. Now I'm going to grab this arrow. I'm going to move it. I'm going to grab this intersection on the tail side, and I'm going to move it onto this intersection of reference lines I had here. Then I'm going to rename it 120 VAC from line, well, I don't know. What line is that from? Go over here, look at my source drawing, okay? That's from line 5. From line 0, 0, 5. Okay, and C drawing 1. All right, because that's where it's coming from. It's coming from drawing 1. Then I'm going to select this line, and I'm going to move it onto the pointy end of that arrow. All right, and then I'm going to do the exact same thing on this side. Move. Put the butt end of that arrow on that intersection. From line 0, 0, 5. Cool. C drawing 1. And I'm also going to move this wire onto the front. Okay, we are almost done with this. The last thing I want to do is yet another reference line down the middle of this drawing. So I have my point. And then what we're going to do is put a power supply in here. So I'm going to come over and I'm going to steal an example of a power supply from my original cannibal drawing. So I'm going to grab, this looks like a nice power supply. I'm going to grab, I'm going to copy, and I'm going to select a point right about here as my reference point to copy from. I'm going to go to the drawing I'm working on. I'm going to drop that reference point right on that intersection. And so you see, when I copied from here, I made the rather intelligent choice, if I do say so myself, to make my reference point of copy arbitrarily right about here, right? So it's centered in the middle here, but it's not on the border, it's inside of the component. And so when I copy it over here and land it on this intersection, it's lifted up a little bit in the drawing, and it's kind of nice and located where I want it. Now I just realized that was a dumb choice because I need to terminate wires into this thing. So I'm going to select it again. I'm going to type move. I'm going to select the edge of this and move it down onto my reference line. Okay, so now the screw terminal points on this power supply can be lined up onto our wire lines. And so I'm going to hide. Actually, I'm going to change my layer to be the EL1. And then I'm going to hide the reference layer real quick because it's kind of in the way and it's kind of blocking what I'm trying to do. So now I can select these 2 wires and just click and drag to extend them out to the termination point right there on my power supply. Do the same thing on the neutral side. Okay, that looks good. And then I just remembered this right now is on the 24 volts layer. So I need to change that to be on the 120 layer. So I'm gonna select this wire, select that wire, change them to the L1. And then on the neutral side, I'm gonna select this wire and this wire. and change them to the L2. Okay. And so now I'm showing I have 120 volts coming in to this power supply, which acts as a little transformer. And what I could actually do here is draw out arrows from the 48 volt supply side of this out in reference to another drawing. So really what I've done here is just shown how you can use these reference arrows to have a wire come from one drawing, for example, from this drawing, into another drawing. And what you're going to do is you're going to keep the wire label continuous across those. And you're going to call out your line numbers. That should say 30, not 59. And so you can use that because at the end of the day, you're not going to be able to jam pack all of your circuit information into one single drawing. You're going to have to break your set out into multiple drawings, and you need to be able to reference connections between your drawings. So that's how you do this. You use these reference arrows. So I know that was a really kind of long demonstration to get a very little bit of content. But one of the points of feedback I got last quarter is that I was kind of going too fast and it was really hard to follow. And so I'm trying to show more minute detail of what we're actually doing in these drawings so that you can kind of follow along. Now, ultimately where we're going with this is we need to actually finish the drawing set for our panel. And so in the last 2 minutes that we have, I want to actually show you our panel and what we're going to be drawing. So that was just a quick little example of power distribution drawing. But now I'm going to switch my other camera to full screen view, and we're going to use our handy dandy little GoPro on a stick. So this is our control panel that we built last quarter. Let me adjust the camera real quick. Hopefully none of you guys get motion sickness too easy. Okay, so this is our control panel. It's got a super nice touch screen that we got to program. It's got all these buttons and lights and alarms that are connected to our controller inside. Okay. Now, what we've been drawing so far is power distribution, and that is this little corner right up in here. So this is our circuit breaker. These are our fuse blocks. These are our terminal blocks. So this is the L1 live power feed on our circuit. It's 120 AC. This is our neutral line on that circuit. Okay. So this is the 120 AC feed in, and then these are our grounding blocks. Now, one of these fuses, this fuse right here. By the way, this is all de-energized. That's why it's safe to use my demonstrating pointer in this panel. You shouldn't be poking around in a screwdriver in a live panel, but this is all de-energized, so it's fine. This fuse right here feeds this 24 volt power supply right here. So you have your 120 AC coming into these termination points. Sorry, I got my hand in front of the camera there. To these termination points, and then you have 24 volt DC power coming out of these termination points and feeding down to our 24 volt power distribution right here. And so the 24 volt distribution looks pretty similar, right? You got fuse blocks, you got terminal blocks, and this is powering this controller and this Ethernet switch and a lot of other various components. And then up top here, this stuff, these modules here are all motor control circuit stuff. So this box here is a variable frequency drive for controlling an AC motor. And then over here, the last thing I want to show you is my jeans that are hanging up to dry. Is the back side. These are the buttons. These are the lights and the alarm, and this is the back side of the touchscreen panel. So this is what we've been working on drawing, and we will continue to finalize drawing. Hey, check that out. You can see both sides of me. Hey guys. It's really disconcerting. So I think what I'm gonna do is in the future, in the very near future, I'm gonna make a video where I go through and kind of talk about each component in that panel, explain its purpose, explain the wiring a little bit, and have you guys just watch that on your own time, so that we can get into more of the programming going forward in the near future. So we have on Wednesday, we're gonna do a little bit more AutoCAD drawing stuff, and then I'm gonna briefly go into ladder logic. So we'll start poking around in the Click PLC programming software. And then the following Monday, we're gonna have a guest lecture from a guy I work with sometimes named Bill Mueller. He's been doing ladder logic programming for a really long time. So I'm actually gonna get him to introduce programming ladder logic and programming PLC controllers. So it's gonna be a little bit of change of pace, but I think he can do a really good job of talking about some different aspects of what you should watch out for when you're first starting out programming PLCs. And then from there, we're gonna shift gears pretty quickly into writing and testing code in that panel that I just showed you. So I'm just giving you a heads up now. We're gonna change pace pretty quickly. On Wednesday, I'm gonna talk a little bit more about homework assignments. We're gonna do some assignments, I think, to clean up the drawing set for this panel and try to get a finalized set that way. And then for everybody on this call, is anybody interested in doing some work on some stuff on SolidWorks this quarter, or are you guys all good on that?
That's not why I'm here, but I wouldn't be against it if other people wanted to.
Programming.
Yeah, I agree. Programming.
Okay. That's good feedback. Well, speak now or forever hold your peace. Because at this point, I think I'm just going to start filming supplemental SolidWorks tutorials. And yeah, we're not really gonna go into SolidWorks. Okay. We have 3 resounding votes for programming, which means that's what we're doing this quarter because nobody's spoken up for SolidWorks.
What program do we need for that? For the programming?
Click PLC programming.
PLC.
I think I went over it in the first lecture, but I'll shoot out an email. It's free.
Okay, cool.
And it's installed on the remote sessions if you're using that for the VPN login. I also screwed up the pacing and went over time. Does anybody have questions about what we talked about today? Clear as mud. Cool. How did you guys feel about the pacing? Am I going too fast or too slow? And is this value added?
A little bit fast, but the stuff that I pick up on is valuable.
Okay. What I'm trying to avoid is like getting overly bogged down, and because I guess we haven't even really created all that much content in this set, right? So it's, I don't know, setting the pacing is hard.
Yeah, like I can follow along and get the basic skeleton of the drawing we're doing.
Yeah.
but it definitely doesn't look anything like yours.
That's all right. Maybe I'll make that. I think I'll make that a homework assignment then after this video. So I'll upload a screenshot of this and ask you guys to between going back and watching this video and the screenshot, try to recreate this drawing as best you can.
I think that works.
Yeah. Are you guys on board for that?
Yeah. Then we get to use all the CAD techniques.
Yeah.
But we don't have to like slow down lecture for them.
Yeah. Yeah. Cause really like just doing all those copy and move and resize commands and like figuring out how to line everything up just takes a little bit of time. So I think at this point, if I was going into it dry, I could recreate this in about 15, 20 minutes on my own. But what's that?
Nope, nothing.
It's not like a brag or anything. I just like that's the actual pace of creation that would go at, right? But me stumbling over myself and trying to talk and draw at the same time, it slows it down a little bit. Plus I'm trying to make sure that I at least halfway explain what I'm doing and the reasoning behind it. So it just slows it down. But time in the seat is what really matters, right? And I think if you get a job where you need to use AutoCAD and you're doing edits on a PNID and stuff, why is that flashing? I don't know why my video is flashing. That's really weird. If you're doing edits on a PNID and stuff, like the value of this class is that you've at least poked around in AutoCAD enough to where hopefully you're not stumbling over your feet too fast and you're not figuring out, it doesn't take you an hour to just change the layer of some lines, right? Go in and do that stuff pretty quick. So that's really why we're here.
What time slot is Bill teaching?
He's gonna do the Monday, I think.
But like 3 or 6?
2 to 3. I think we're gonna cancel the 6 o'clock time slot because last week one person showed up.
Oh, okay.
So yeah, I'm not about that life. I feel bad for the one person, but they can watch YouTube. I feel weird. I would feel weird trying to present this to one single person,
Yeah.
So I don't know. Maybe that would be good. Maybe that would make actually a better recording. What do you guys think?
Presenting to one person?
Yeah.
I vote for you living your life.
Yeah.
Yeah.
You and my wife, buddy. Cool. All right. Are you guys actually going and watching the YouTube videos as reference at all, or nah?
Yeah, to do the last homework assignment, I did.
Yeah. Okay.
Yeah.
Dope. Good. I'm glad. That's all you added then. Sam, I need to talk to you and anybody on this call that's I don't know if anybody on this call besides Sam is going to be at Davis next year, but do you have like 5 minutes to talk, Sam?
Yeah.
Okay. So I talked to Dr. White. I'm going to kill the recording actually because this